All right, so like I said, if you go here under geoprocessing, you're going to have this here. Then under geoprocessing, the first thing we're going to start exploring here is the tools here, which is analysis tools. Under analysis tools, here we have extract, here we have overlay, we have pairwise overlay, proximity, and statistics. This is what we're going to focus on for now. And under extract here, we have clip, we have select, we have split, we have select by attribute, we have table selection, and here overlay we have apportion polygon, we have count, we have erase, identify, intersect, remove, join, we have symmetric difference, we have union, and we have update. Now in our next meeting, we're going to be using spatial. We're going to be talking about spatial joining. So that's what we're going to be doing on this one in our next meeting. So we're going to be doing spatial joining. Then here we have proximity buffer, near polygon, ring, near, and rest of them. And then under statistics, we are going to also explore tabulated table, so whatever is needed under this, so we are going to explore them one after the other. Now before we proceed to that, if you come home, you're going to see selection. I've a bit explained a bit on selection. Now under selection here, there are other tools associated to selection here. When you click on select by rectangle, so that means if assuming I have a point I want to select and I drag this rectangle across it, that's going to select what is within this rectangle. Now the same way, if I need a polygon, so that means if I click across a polygon like this, and that's going to select what is within the polygon here. So maybe I might need to increase the size of this. So let me increase the size a bit, so that I can have a bigger size. So you can think this is better a bit. So if you look here, this is for polygon. Also have to do with you selecting, dragging your mouse, and this gets you selected whatever that is within this region that you click select like this. And then circle means you click on a point, and the more you drag across the circle, and that's how this is going to select within the circle. Line, if you drag a line across it and any one of them that touch the line, that's the one is going to select. And then we have other one like trace, box, sphere, and cylinder. Yeah, so that's all about you selecting manually. Now we go to select by location. Now this only select for you based on the location. Now assuming the way you guys were working on, and I told you people to go ahead and use the one that is in Kigali, and I believe that's exactly what you guys use. How do you select? I'm a bit reiterating this because of Honore, because I believe that all of you have known how to do this one. If you look here, you see that I have the one in Kigali. So if I want to actually select, I can go ahead and select Kigali here on this particular layer, and Kigali is selected. And here I want to select the held polygon that are within the Kigali. So which of them do I want to focus on? So I want to focus on admin 1, and in this one that intersects, so if I click apply, you see that because I selected Kigali, because Kigali is selected, now what happens, every location that fall within that intersect at Kigali has been selected. So if you look at this particular point, now you see that the only one that is selected on this particular point here, this point of held facility, this one is the one that is only in Kigali city that is selected. Why? Because I only selected Kigali. Now the same thing, if I changed my selection to the Eastern Province, as you can see here, and I want to select only one that is Eastern Province, so you can see admin 1, if I click apply, you see that the only one that is going to be selected is the one in Eastern Province. But if I clear this and go ahead and click apply, what happened is going to select everything that is within Kigali, because this is the layer. So in ArcGIS, what happens is the layer that you selected become the target location. So you can see the way I select it, and if I click apply, what happens is it automatically selects the one that I select. So this is just how to get it done as related to that. So but there are other tools here, like you can see 3D intersection within geostatic, within a distance, within a contains within with that are identical, that touches the boundary. So this one, depending on what you want to select. But just what I want you to know to get is that if it is within a distance, searching through the distance, for example, I select only Kigali in terms of administrative boundary of Rwanda, and here there is option for you to say let's use kilometer, and if I change this into 1 kilometer, now what happens is if I click apply, then you see that it did not only select Kigali, it selected the one in Kigali, but it goes beyond to select something that is outside Kigali. Why? Because I say when you are selecting, look for the rest of them that are within 1 kilometer of Kigali. Now that's why if you look, take measurement tools, and then you click, let's say from here to here, you see that it is within 1 kilometer. So this you can also change to from imperial, you can make it in matrix here, so that you can actually see that this is within the 1 kilometer of Kigali, and because this point is within 1 kilometer of Kigali, and that's why it is selected. So once you say select the ones that are within 1 kilometer, so if you increase it to 10 kilometers and you click apply, so what happens to it? You see that what is within 10 kilometers of Kigali will be selected. So in this way, this is a partially a way of making a kind of inquiring, like there is a point or protected area or point scattered around Kigali, and then you are asked to make sure that everything you are selecting, you give it a buffer of 10 kilometers. So this will get you done. Like example is, this is health facility, and maybe they say somebody that is staying here, for example, if you are staying here, you know that it is easy for you to go to this hospital than to go to this hospital by the right hand side here. So you know that if there is something that happened and they are making an analysis that you want to say, oh, I want to see what is happening I want to see what is happening, how which of them are proximity to people living here. So if you look here a bit, so let me 1 minute imagery, and turn off this. Now let's look at Kigali. So this is the boundary here, and if you look at this particular hospital here, you see that even though, let me assume that there is a bridge that crosses here, and then people that are staying here, for people to go to hospital here, it is easy for people to go to hospital, that anybody like this building you are seeing here. So assuming that there is a bridge here that let the person crosses, you see that it is easy for people here to go to hospital here than people going to hospital here. So because of that, you can make a kind of analysis that you check within this particular parameter. So what happens is, if somebody is supposed to go to hospital, we now say I need to go here because it is closer to this particular hospital. So if you look at the Rwanda administration, you see that even though that this is not in Kigali, but the people here have easy, quick access to hospital than going towards the Kigali. So they will decide to go to I think this is the southern province because it is closer than what is here. So what I'm saying is, when you want to add a distance, so you can also make a kind of inputting a distance here. So this is when it comes to search within a distance. So you can add the distance, you can define the distance parameter, that is a unit of the distance here, and this should be able to query within this particular location. So this is when it comes to query by location. So once you have the location, you have the layer, then you can query within the location. Now let's talk about querying by attributes. The query by attributes is a different one. So this one, you focus on the attribute based on the attribute table. Yeah, now you will need to understand the attribute table. So how? Because the attribute table have their names here. So you see here that in the attribute table here, let me close it a bit. So we have a 0, we have point, that is field, point, amenity as a hospital, depending on what you do, the shop, the name, the healthcare and phone number. And then somebody asks you, oh, I need you to use this attribute to make the query. So attribute table is what comes in play here. Now you have selected the health facility, and under here you have select. If you remember, we talk about standard query language or structure query language, which we have select from where. So in this way, if you have idea of programming code, you can turn on this. So you go with select from where under this one. So you see here order and rest of them and the vertical. So you can start your attribute table by selecting from where. So the column, you go in. If not, you leave it by manually like this. So which you need to clear this, and then if you turn it off here, it's still the same thing you are trying to select here. So the same procedure apply here, where you say where feed. So where are you talking about? You are selecting from where, and you see here that you have selected the health facility. Remember that this is supposed to be toggled on. Now if it is a new selection, you will know. If it is to select from the already selected one, you will also know. What do I mean? Now you see now that here I say select from where. I have already selected from where. Now I want to select from the attribute table that are hospital, that is not the ones that are hospital, that the one that is hospital but not pharmacy. So that means I need to look at this attribute table and I say I'm selecting from amenity that is equal to, now that is equal to, and I will say that is equals to hospital. So you see here that equals to hospital. If I click apply, everything that will be selected are those ones in the attribute table that are equals to hospital. So you look here, you see that the ones that are selected are the ones that are hospital. Then you can also say that you select the ones that are equals to pharmacy, then you click apply. The ones that will be selected are the ones that are equal to pharmacy. So this is exactly a way you can build the attribute table, and then the way you can build your query to select from the attribute, not now selecting from location. So you can see that the record processed here, you can see here you have 334, and here you have 334, which I have shown here for you. So this is a way you can express your query, and that gets to select for you. Now in ArcGIS, we don't have this written like this for us. Now in ArcGIS, we have the ones that are written, it is written with equal to, or not equal to, or empty. So this is a way it is written in ArcGIS, but in ArcGIS Pro, it has been changed in such a way that you can see all these things here. So you don't need to stress yourself up. So if you say here that is null, then let's use the phone number for example. So we use phone and we'll click apply. So what happens? There is no phone number that is null. So if there is, it is null. So you see that phone, because I'm using the attribute of the table, that is null. So you can see that now. So if you want to look for the one that ends, so you see end with a phone number that ends with 64 for example, and then you click apply, then you can see that this particular phone number you see here have ended with 64. So you can see 64 here, and then if you switch it, you see now that you have 64 564 864. So you can use this to query for phone numbers. So this is using that ends with, so it makes things easy compared to what we have again. So you can also look for something that have to do with something. Now let's say somebody is looking for a particular hospital and the person don't know the name, but it have idea of what it contains. Now this is a way you can query it. Now it is just like you querying the entire data set, which as you see here, the total hospital we have here is 1076, and you want to look for somebody, a hospital that end with 64 in their phone number. So you can use this to get it. The same thing, you can also look for the name of a hospital that contain, so you can see here that is equal to, that is not equal to, that begins with, that does not begin with, that ends that. So these are values you can explore. Once you notice what is in the attribute table, you should be able to use this to make a query on it and perfectly get those information again. Like just like you see here, I was looking for a phone number, any hospital that their phone number end with 64, and then I should be able to get it. This is does not begin, this is ends, this is does not end. So all these things are completely done for you. And if you look here, you see now that if you switch to standard query language, you will see the query that you have viewed, which is phone number like 64. So in this, you need to know how to use SQL table for you to standard query language for you to understand this. But if you look at what you viewed earlier, where we say amenity that is equals to hospital here, and then you click apply, and you select all the amenity that is equals to hospital. If you turn to go to SQL language, so you can see that here shows you amenity equals to hospital. So you see now this is the conventional one we have been using in ArcGIS. So this is how you query in ArcGIS, and then it gives you. But QGIS, ArcGIS Pro have actually simplified this for you, and that's good. So you can also add a this thing here. How? Let's go that amenity that is equals to hospital, and the phone number that ends with 64, like I rightly have queried before. So now you're bringing two query into play. Now you can see now that this is and. Remember when we're making query on overpass and we're talking about or and. So this is where I'm also bringing this. Remember what I said earlier, that when you are making a query, the query has to be, when it is or, any of the statement can be correct. But when it is and, both statements have to be correct. What it means is that get me the hospital, get me the amenity that is equals to hospital. That statement must be true. And the moment you put and, it means that both statement 1 and statement 2 must be true. So what do I mean? If you look here, see that when I say and, I am referring that both statements must be. The first thing is that you realize here is that the hospital here, the amenity here is equals to hospital. That statement is true. But here, the amenity also have a phone number that ends with 64, and both statements are true, and that's why we have this query. But when we go to or, you means that any of the statements must be true. So when you say any of the statements must be true, is that first, give me all the hospital that are amenities that are hospital, and or any other hospital that have end with 04. So that's why you have now 637, because any of them is either true. So any of the statements are true. So if you also toggle the SQL, and you can see here what we have here, amenity that is hospital or phone like 64 are things you are going to have in structured query language. Now this is and or, and then you can build a different order this thing here. Now before we go that this is containing a text, and this is null, not null, less than, does not include a value, so you can check any of these. So if you put up to a structured query language, so you should be able to have that as well. So now if you look here, you see that I said not equal to. Now is not equal to, now that is hospital. So what happens is, if you want to make a query that is not equal to, in standard query, structured query language, I use this. So not equal to means give me every hospital, every amenity here that is not hospital. So I have specifically say that is not hospital. So the structured query language builds it like this. While the normal way of querying them build it like this, the amenity that is not hospital. So what happens, every amenity here that is not hospital are the one that are selected. So in this case, you need to understand this, because you will be working with a big data set, and when in that big data set, you need to understand how do you work within this particular part. So this is a way you can make query by attribute. So with this, you should be able to have this understand perfectly. So this is the way you can make attribute query. So if this is okay for you and it's easy for you, that's fine. If not, you can toggle by using the structured query language here. And once you get that done, the structured query language should be able to get that done for you. And at any point in time, you can always click here to refresh. So this is just what the interface done here. So with this, you can make a query and select whatever you need to select, or build any query that you need to build and select. Now, in a data set as well, when you look at this and you return here and you go to properties here, now you go down here, you see what we have as query definition. Now, query definitions also helps you get something done. Now, if you look at this data set now, let's say that I ask, when I was telling Lydia to do the map of Kigali City, and then Lydia have the map of Kigali City, and she don't want to go ahead and start making query on these things that I was talking about, start making this kind of a thing, but she still want to have the data and she don't want to create a new layer for this particular data set. What will she do? She can go to query definition here, as you can see, and she can click on add query, and on the adding query, I just want to toggle these things and paste these things that I copy here and apply, and I click OK. Now what happens, you see that what happens here is that this data set was 1007. Now these data sets are still here, but the difference is that everything that do to do with hospital is no more here entirely. Now, where do I take that done? Is in query definition here. Now I've said everything that have to do with hospital, remove it from the entire data set. Now, even if I close everything here, and one thing you notice is if I click on clear, now the whole data set has been reduced to 444. Even if you close the attribute table, and if you look at this data set here, then you see that everything here has been reduced to 144. Even if you go to attribute table here and open up attribute table, and you see down here that what you still have here have only to do with, you cannot see hospital. And if you go to query attribute table to query and you still go to hospital, and they say that amenity that is equals to hospital here, so I'm using that equal, that is equal to hospital, and if you click apply, you won't be able to have anything, because the query definition have actually get this blank off for you. This is very, very important, because you might have a data set and somebody tell you that you need to do this, and you don't need to remove those data sets. You don't need to start querying and saving as a new layer. So you can use query definition to define what I just did now. So now the data set is here, but the difference is that using the query definition, I was able to remove the every hospital while retaining the data structure the way it is. So at any point in time that you want to go and remove it, still come back here and you can edit it here if I say give me only one that is equal to hospital and I click apply, what happens? All the pharmacy and everything will go away. So you can see now it have changed to 633, 32. So everything that have to do with pharmacy will now go away. Like every other thing you see now, the only thing you're going to have here are the one that are hospital. So query definitions helps you get this particular thing solved. Now, why you still retain this? So anytime you want to get that, just go to properties and you go to query definitions. And if you want to take it off, you just click on this and then you can delete this layer and you click apply. Okay, and then you see this return your data set to normal the way it ought to be. Now, this is it here. This is about the query. Then let's go to another step now. Why I explain this is I want you to understand this structure, the what I'm talking about, and then get to understand what I'm saying right now. Now, before I proceed to buffer, I am going to start with the first processing tools here, which I'm going to start here, and I'm going to call it identify. So in this particular way, you see the way I have this particular layer. But you see now that when I look at the location here, I'm searching it by location. Now I'm going to probably return back here and then go to data sets and go to Rwanda administration here. And then I'm just going to copy this directory and I'm going to add the layer of the village. So I'm going to paste, and the districts, this is Rwanda, provinces, districts. Yeah, so let me use the district for now. So I'm going to add the district layer. So you see now that in this particular data set here, as you can see, this is the Rwanda districts. So if you right click on it and say click on label, and then you see Rwanda, go to label layer and change the layer to class name to name, let's say name 1. Is it name 1? Let me check. Yeah, no, let's go to name 2, which will give us the name of the district. So you see here now that we have different districts in Rwanda, as you can see now. But this particular point here does not have the name attached to it. So you can see Gasabo district, and then if I want to know this particular layer by this particular way by the layer, how many of the hospitals located in each of the districts. And what I need to do here is what we call identify. You can identify, you can intersect depending on whichever way you want to go on it. So for this, I'm going to start with identify. Now identify compute the geometry of the input feature and identify with the feature. The input feature or portion thereof overlap and we generate attribute of those features. So what it means is that for the fact that I have this feature here and it's a district, and I want to know how many of the 30 districts have more hospital among what the data based on the data set I have, I'm going to use identify tools. Now intersect here almost does the same thing, but the difference is that it compute the geometry intersection of the input feature, features or portion of the feature that overlap in all the layer of feature class will be written to output class. So this one, intersect and identify, we might see the difference as we go on. But in this way, I want to get the features that are in this Nyarugenge district and rest of them. But you know that this particular data set that I have here does not contain such information. So what do I need to do? I can decide to say, let me use identify. In identifying, I want to identify the health facilities that are within the facilities of administrative 2 here as a district. So this is identify, and I just want to leave it on the default location. So if I want to edit it, I can edit it by this. So I can say hospital and then I'll put district. Now this is here. You can decide to keep the relation. Anytime you get to here and you don't understand what it means, you can click on this question, and this question tells you it specified additional. If you check it, no additional relationship will return at the output. If you don't check it, you will also need to know what it does, so you can always check on this. So if you run this, what will you have? It is going to identify it with the view, the district, and when the data set is added to you, so you can see the difference between them. What are the difference? You see here that we have the name alone, but if you open up the identifying here on this one, then you can see now that this has hospital and this is where it stops at phone number. Then it goes into identify what? It goes into identify the other distinct, adding this to you. So you can see here now that you have the district here. Look at the district here. So you see now that this point have merged automatically the other this information into it because I'm using identify. So it now identified with this particular one. Now let's go to geoprocessing again as we are working on, and then I'm going to return back here and I'm going to go to intersect. Now in the intersect here, we are going to use the health facilities again, and then you are going to use all the attributes here. Then you say only identify with these IDs, so if it is for IDs, and then identify with the IDs except. So this also work with this is giving you point line or polygon, so you can see a little bit variation on intersect and this, but that's not where my focus want to go on. Where my focus want to be is you getting this thing up Italy. So if I tell you how many hospitals that are within each of the districts, so you can quickly tell me by going to this particular table, go to the attribute information here, you can click on this, and then you see under data engineering here, under data here, and then you can see the attribute information. So I can click on data engineering for this, and you see this has been dropped here for me. Then I want to get it by district, so you can see here I think name 2 is by district, so I can drag this in and drop it here, and once that is done I can calculate, and you see here now that this has actually been added here for me. So for me, you can see now that all the category 17% are in Gasabo district, then 19% is in Yarugenje, then Kichichiro as well. So you can see the proportion of this particular so if you want to open it, you can create here by creating a chart, a bar chart, or you can open it here, and this is going to open up the chart for you. So let me drag it a bit here, and you can see here the number of the hospital as located by each of the district. Why? What comes about this? Let me rotate it a bit so you see the number here. How does it come about? It comes about because I was able to intercept the data of the district to bring all this information as it is. So in nutshell, this was able to give me this aspect of this because I was able to get intercepting the data, and I know the number of hospitals that contain is this, and the number of hospitals that are not in district is this. So this is a perfect way of getting this done. And if you look at this, you see now that it have labeled it based on the number of the hospital. You can see Gasabo, Kichichiro, Muhanga, and rest of them. Then you can see the number of hospitals as each of them contain. Then you can go ahead like the way we talk about this, label it, modify them, and give them all like the title. You already know how to make the title, like I showed you here. You can change the title here. Now in intersecting, you can also split this by saying I want you to split it by field of admin 2 or field of ID 1, depending on how you want to split. So if it is you are splitting it, so if you click apply, you should be able to split it for you. You can also put it by ascending or descending like this, or you can put it by customizing it by ascending the name A to Z. So depending on whichever way you want. If you want to label the bar, you can label it. You can see the number of hospitals are within here. You can add it as a chart, or you can add it to the map layout. So generally, this helps you get this done. So if it is by district, so you can add it by district. If it is by provinces, you can add it by provinces. If it is by sector, you can also add it by sector. But generally, this is how you are going to add them, and should be able to work with it perfectly. So in this, you remember that if you change this to layout, like I said, this is also important because you'll be producing map that have this to do with this. So if you remember here, all of them are showing the same color. But if you go ahead and say administrative level 2, go to symbology and then change the symbology and change it with, let's say, unique value, and the ID you are going to select is name 2, and then you are going to click apply, and this is already changed for you in this pattern. So you already know what I did last time and how I did it in the study area, so you can also get your own done that way, in such a way that if you return back here and you want to add the chart, you should be able to make a reflection of what the relation of what is here to the color that you have here. So still that same way, that's just the same thing you also need to done. So if you click on preview here, you can also create your own. If you say create, you're going to create here a bar chart, and that's going to open up for you. So you can see I've added the layer here for you. So this is just generally, so I can remove if I want to remove, so I can delete them. Now this data engineering helps you get quick chart. How? If you look here, you see that if I go to name 1 here, I want just to drag it and drop here, and it's going to compute for name 1 for me. So if I say calculate here, like this one, I can click on calculate here, and then it's going to put it up for me. So if I want to see it by Rwanda, I can now go here, right click and open chart, so you can see it by the provinces. So these are the number of hospitals based on the province. So you can see here in Kigali we have 394 in that particular order. So how the data engineering is what I use, or data engineer, whichever way. So I'm able to use that to produce that. So if you go, like I say, if you go to data, you should be able to go to data engineering, so you can see what you can do here. Feed attribute table, and you can clean depending on how you want to clean it, and then construct. You can also make this kind of construction depending on how. You can also integrate by join, by feed, near, summarize, within, sample, raster, enrich. Then this is the formatting. You can format time feed, zone, by vote, and rest of them. This is how you can use this, but this is a quick one. The moment you drop it here, you should be able to get the summary of what you have here. So if you look at this table, so you can see the percentage, 36% are within Kigali, then the rest of other one are within the range or the time it is. So this is how you work with attributes in a table. Remember, this is not applied to hospital, so I'm just trying to tell you this because it's not just only hospital. So this can be applied in different way, not just only hospital alone. It can be applied in other aspect of your work. So this is working on intersection, and then let's move over to making a buffer, which I know all of you have actually known how to get that done, but it's also part of the things we just need to touch. Now if you look in here, we have what we call buffer here. Now the same way, for those who want to get that done, so you go ahead to your buffer. So I might need to close all this, so we might not need it for now, I think. Yeah, so you see the hospital that are here, and you are asked to make analysis of the hospital that are within a particular distance. So simply, buffer is making a specified distance around an object or feature. So if I say buffer for Rwanda, it means you're making a buffer for entire Rwanda. If I say it is a point, you are also making a buffer for a point, meaning it can be a line or a point or a polygon. So a buffer does not have to be around a point. Now I know that you're in Rwanda, you can be hearing about a buffer zone, buffer zone, buffer zone. So most of these things are being used in this particular pattern. So what do I mean by using it in this way? Because when you have a point and the one that say you need to stay away from a point, so let's say a road, you need to stay away from the road, or let's say this particular water body, and it says we need to give a 10-kilometer radius around the water body. So what it means is either it is a road or a road, or it is a point, or it is a polygon. So you can make buffer around it. Like this is an agricultural area, and it is said that we don't want people to live around this place here. So now this is where it comes in. So you need to understand this particular buffer. So you use this to get that done. Yeah. So you can see here you have this is buffer, this is create buffer. So I'm looking for everything that have to do with buffer. This is pitwide buffer, this is graphic buffer, this is multiple ring buffer. You have other different types of buffer, as you can see it here. So these are different buffers you use that you can find in geoprocessing. For all things being equal, so this is a buffer which you need to use only points, like a point of line or polygon. So now what do I mean by buffer? Like I said, a buffer is used to make a kind of specify point around an object, either it is line, point, or polygon. So assuming you want to make analysis here, to use this health facility to say how many of these that, let's say that every hospital in Rwanda, depending on where you are, have to be within 10-kilometer radius. So maybe 10 kilometers is much, but let's say anybody in Rwanda is supposed to have 1 kilometer access to hospital. And never mind that this is not all the hospital, either health facility or health post, or I don't know what names you call it, or district health. So every individual is supposed to have access to it, and you are asked to make a buffer around it. So to know calculate it, so you can use the buffer, still use the health facility, and then we need to make a buffer of 5 kilometers, and you now need to put it up here. So unit of the distance here. So if you have a field, you go ahead with the field. Maybe I will create a data set so that we can work using the field, and I will explain better on how to use the field. If not, if you're talking about linear, it's just the same distance. Now when you're talking about field, it means that in each of the data set you have actually identified the distance you want to have for each of them. You go ahead and use it. If not, you can use this one here. So I'm going to say 5 kilometers radius. So once you go up to this, then it means this is planar, and this is dissolve. So we're going to talk about dissolve, but I want to say no dissolve for now. And when you run this, it means that it's going to make a 5-kilometer buffer around all the objects of the health facility. And you can see here that this is the buffer ring. That means that some of the hospital here, as you can see, in some of the part of Rwanda, some of them are not within 5-kilometer radius. So you can see the gap that are here. So it means that if people are living in this particular place, so if I turn off this, so let me collapse this and then turn off this, and you can see the imagery. So you see now that here is Nyungwe forest, so there is no problem. So if you look at Rwanda course, you see that that is Rwanda geodetic network. You will understand what I'm saying, that there are some of the places there is dark spot, that the network are not overlapping. So to this, when you look at the hospital, so you see that some of the places that there is gap between them. So it means that somebody living here, I don't know whether there is a house here, that's why I switched to this, but there should be, look at a house here. Yeah, this looks like there is a house here, so you can see a house here. So it means that these people that are living here are part of the people that does not have access to 5-kilometer radius of the hospital. So you can see what I'm talking about here. You see there are spaces within here. Now if you go to Geoprocessing Tools again and then return back here, and then you go to within, summarize within, so you can see now that if you want to check on the buffer, as you can see here, if you want to say summarize within, or you want to check all these ones, you see that most of the places have so much overlapping. Like people in Kigali have so much ring hospital around them. So as you can see here, there are so many of them. So if you go ahead and say let's use the layer of 5 kilometers, and then let's input let's also input the feature. So I want to still use here, and then I want to use administrative too, and then you can say ID and statistics. So let's just leave it like this within the square kilometers here. And you see that there are several hospital there are several points or positions of this hospital that so much overlap or intersect with each of them. So if you look at this, you see that if a point, somebody that is living here, you see that about 50 or 80 hospital are within its reach. So that means the probability of this person going to hospital closer is higher than somebody that is staying here. So you can make a multiple choice that, okay, I don't want to go here, I want to go here. So you see that you have more option than somebody that is staying here, because this person here have only one option here. Like say somebody that is staying here now, what option does the person have? The person have to come here. But also you know that the population is also have a way to play, because somebody that is staying here, there are no more populated people here in Kigali city. So you see that there are many people living here. So the person have many options either to go here, because if you are staying here now, for example, you can see the number of places, hospital options that you have. But somebody who is staying here have only one option to go to this hospital. The person have only one option to go to this hospital. It is not the same thing with somebody that is staying in Kigali city, because somebody staying in Kigali city have more option than somebody who is not staying in Kigali city. So these are a different analysis you can do, and you should be able to make your decision based on that. Keep all environment message. Yeah, I am looking for the output of what I did. Yeah, but don't know why it's not showing up here. Okay, so I wanted to like make like explain. This is summarize. Okay, yeah, this is what I'm looking for. So if you look at the table that I have here, and then if you look here, you can see the count for polygon here. Let's quickly right click on it and say assort it by ascendingly. So you can see here the first one here, this is, let's start with this. So this is in one category, but if you look at the count of polygon here by descending, you can see here we have up to 4 categories. So if we change it to what I wanted to, this is not what I wanted to do anyway, but if we change it and put the right parameter, you will see that one of these polygon have more than, like if you check the number of overlap of this polygon, you can see that it is more than even 50, meaning that somebody who is staying here have higher chances of, you can see what is highlighted a bit. Look at here, somebody who is staying here, you see that this person staying where I click now have almost 85 chances of reaching to the hospital. So that means the probability of going to the hospital here is that this person have more 185 hospitals like within here to attend. But somebody who is staying here, you can see where I selected at the center here, where I click on the 300, it's 185. But somebody who is staying here just have only one option of going to the hospital. So this means that the probability of somebody surviving rate, if it is by hospital, is high. So I'm explaining this because we have to make different analysis and come up with like if you want to make modeling or simulation, this is what you can do. So you see now that people in Kigali have more access to hospital, because somebody who is staying here that I click have more access to hospital. If you look at the query I'm doing, this person is almost 280, meaning that if you're in Kigali and the parameter for choosing hospital is by 5 kilometers, you see that one person or one family home have about 280 overlapping hospital to attend to. But somebody who is staying in the eastern province somewhere have only maybe one option, or somebody staying here have only two options of hospital to go. So it means that if there is a head or issue, the people in Kigali have a surviving rate. Though if you divide it by the proportion of population, you might see that probably there's advantage of being in the eastern province. Now this is all about making a buffer, because you said make a buffer within these zones, and this is a way you can get it done. Now when it comes to buffer around the protected area, we are going to do what we call multiple buffer now. The same thing we did, but I'm going to go to Geoprocessing tools again here, and then I'm going to return here and then close up this, and then you can see here we have here, this is ring buffer. Now ring buffer is used when you want to make a kind of buffer that have to do in multiple. So in that way I am going to use Kigali as an example of getting it done. So I'm going to turn off this, and I'm going to turn off the buffer. So I'm also going to turn off this to leave this. So I'm going to turn on Kigali Administrative 1, and then I'm going to click on this as the first one. Then in Rwanda, so in that way I'm going to make a selection of Kigali, because I just want to use only Kigali to do what I want to do. So I've selected Kigali, and I'm going to go to buffer here. So let me clear a bit my screen. So I'm going to go to buffer here, and I'm going to input a Rwanda Administrative 1, and I'm going to make a multiple. This is a multiple buffer. Now on this, you see here that we have a unit here. You can change your unit to, let's say, in kilometers. So let's go ahead and make it in kilometer. Now this is a distance. This is dissolve option, overlap or non-overlap. This is non-overlap, and this is overlap. So this is outside only. If you click on this, that means go only outside. Then here is a distance. I've selected kilometer here, and this is Kigali city. And let's say that the government says they want to compare a buffer, add more to Kigali city. So let's go with a buffer. So here you have to add a distance, and it's in kilometer. So let's start with 200. Let's start with 2 kilometers, for example, and then let's add another 10 kilometers. Then let's go ahead and add 20 kilometers, and let's go ahead and add 50 kilometers. That's big. Well, let me stop at 20 anyway. So you can add all this, and then this is buffer. You have selected Rwanda, and then you click on run. Now this is going to create a multiple buffer from 2 to, so this one you use this in when you have agricultural land, and then you have, let's say, when we're having a water body and Nyabarongo River, and we want to make a buffer around Nyabarongo River, and then we wanted to say Nyabarongo River, we want to have 20 meters from Nyabarongo River should be protected area. Let's plant 3 there. Then from 20 meters to 40 meters, we want to do crop there. From the river to 70 meters, we don't want people to live there. That place should be used for park. And then you remember when they are working on all this wetland, and they wanted to create something around it. So you can use this particular method to get that done. So if you look here, you see that this is a buffer that I have done here. And if you open it up here, so you can see in the attribute information here, you can see the distance here, the first distance here. So let me turn off this, so you can see the buffer for Kigali. So this can be used for simulation, this can be used for both disease outbreak, this can be used for any emergency, this can be used for different places, so you can apply them in different ways. How do you apply them? So by making a kind of this simulation, as you can see here, so I'm able to have this buffer around them. So if you go here, right click on it and go to symbology, and you select this thing. So let's put it by unique values, and then you will change this to the distance as we see, and let us click apply, and let's now probably change it to another color of our choice. So we can see here that this is Kigali, or this is 20 meters, this is, you can see here, this is 20, so this one is 2, this is 10, this is 20. So from Kigali you are able to make this kind of buffer. So if it is a continuous, like when we're talking about COVID-19, for those who were around then, so you see now that you want to protect this way, and somebody tell you that maybe this COVID-19 need to be contained within this, so people that are here are safe, people that are here, this is danger area because there is somebody found here that is having COVID-19. These people are a little bit less safe because they are staying here, and these people are free. So this can also be used to model in different aspects. Let's say that this is a water point, or let's say that there is a water here, and then it is polluting, this is polluting the river. So you can also make a buffer like this and say, simulate it like this, that oh, this is what is happening within this particular place. So if you go to wetland, you can also use this way to also get this done as well. If it is by simulating water, so you can go ahead and use that to make a kind of simulation when it comes to water. So what I'm saying in essence is that there are different ways, or different way you can get that done and perfectly. I'm looking for a particular data set. Let me check if I can find it here. So I wanted to like let me hope it is what I'm looking for. Unfortunately, it is not what I'm looking for. Yeah. Okay, it is in KMZ, but I just wanted to show you, like, if you have a wetland and then you are asked to you have a wetland and you are asked to make sure that those places are protected. I'll look for what I'm looking for. Maybe I can't find it well. But if you have a wetland and then you wanted to also protect it, so this is part of Nyabarongo River, Nyabarongo wetland, and as a GIS analyst, the government wants to protect these places, and then they want you to make a buffer. You can also use this to get that done. So you can see here, this is part of Nyabarongo River that is falling within Rwanda region. Yeah, I used this when I was doing a particular analysis. So you can now advise them that, okay, if we want to create this kind of zone where we have this and this, so this is what we're going to do. How are you going to do that? You're going to bring this and make a buffer, and then you can say within 10 meters here and within another meters here. So I'm going to bring data because I'm going to show you when you are doing expropriation, how do you overlay this. So we are going to use the data we collected in the Eastern Province, the places we are mapping, and that's exactly what we're going to use to get that done. So if you have this and there is a need for expropriation, so how are you going to calculate the cost? How are you going to know how many people are staying there, how many people are affected? And if you are also doing a road construction, how are you going to get to know people that are staying within those regions? So I am going to get the data prepared so that we'll have data to do that, and we're going to use the Eastern Province where we map to simulate that. So we overlay them, and we're able to know that how many buildings are being affected, and if it is the building are costs, each of the building are cost by this, how much will it cost the government to expropriate and pay them for compensation? So we're going to get that done, and then this is just example of what I'm saying. So if you have this Nyabarongo River, and then the government want to say, okay, we want to make sure that we protect this particular Nyabarongo River that is within this side. Because of that, we need to have about a buffer of 5 kilometers off from it. So any building that's within here that's needed to be expropriated. So you can use that means to get that done. So basically, this is when it comes to buffer, and you can use that to get that done. Then when you say non-overlapping, if you change this to dissolve, what it means is that you are going to merge it, which is dissolve. So we are going to extensively look at that. So that's why we're mapping. The places we're mapping, we're basically going to be using the data to make a lot of creating. And when we get to geoprocessing, and then we get to uh, this summary statistics or tablet intersection, I'm going to explain to you what all this means and why we are going to use them. Because, for example, we want to create a road, and we say this in the Eastern Province. I want to know how many people are affected, or which of the provinces or which of the sector are highly affected. What percentage of land did it contribute, that did it cut off? So we're going to use this tabular tablet to get that done. That is tabular statistic to get that done. For example, what I mean is that if you overlay the district of Rwanda, this is administrative level 2, and you can see here that this particular Nyabarongo River I put up here, it cut across how many? 1, 2, and 3. So if I ask you what is the percentage of this Nyabarongo River that lie in Rulindo, that lie in Kamunyi and Nyarugenge, so you don't need to start drawing it. With this analysis, you can tell me that this Nyabarongo River, 50% of this Nyabarongo River is falling in Nyarugenge, Rulindo, or this. So we are going to get that done. I will need to get those data, and then we are going to use that to make such kind of analysis. You can apply it during road construction, because you are a surveyor. You can work as engineering surveyor. You are also a surveyor. You can work in GIS analysis or a GIS hub. You are a surveyor, so you can work in different places in helping government to make decisions. So this is why you need to understand this and know where do you need to apply them. So in nutshell, or in general, we are able to talk about the attributes, location, selection by identifying or intersect. We are also able to talk about how you can buffer, and then you also talk about to use multiple ring buffer, and then we also talk about, we have not talked about the res, because we are going to use that, and then count by overlapping polygon. This is 5 kilometer radius a bit, and minimum count overlap, and then output the table. So we are going to run this, and this is what I was looking for then. So we have used summarize within. We have used, this is count overlap. So this is what in counting overlap, and this is when the result is out, you will understand this particular part I here. So you should be able to know how many of the polygons that are overlapping with each other. So in geoprocessing, we use count polygon here. This is count overlapping polygon. So this will help you get to know how many of them are overlapping with each other, and you can say these people have more advantage over these other people. So the minimum, which can be 1, which of them that are overlapping. So if you change it, the minimum count, you can also specify it, and then you should be able to know how many of them are overlapping. So if you want to make modeling or simulation, you should be able to use all these data to get that done. So I've given you where it can be used: in protected area, in hospital, in disease outbreak, in road construction, in most of those things. So all those things you need to measure a distance. You don't need to, since it is a large area, even if it's a small area, you can also use it. Like even if it is your plot or a small specific pieces of land, you can also use that to get that done. But the whole important thing is know where to apply it, when to apply it, and how to apply it. It's what helps you make decision quickly and be able to make a kind of simulation. Like we are giving an example and we are simulating and we're saying that this number of people are staying in this. So if you have this kind of overlap and then you have a population, you can train the model and then be able to say that the people are in Kigali are more advantaged than people in the Eastern Province. But in another way around, you should also know what are the distances, the hospital that are within each them, how many are them. So this is not only applied to hospital, it can be a part of you analyzing electrical for reg. You can also be you making a market analysis as well. It can also be you making different things. So in this particular way, so you need to understand how each of them work and then be able to apply it at where it is needed. So on this, I think I will stop here and then I will give you a room to ask your question